Wildfires have a devastating impact on human and animal life, property, biodiversity, air quality, local economies, and so much more. In this week's On Orbit podcast, we hear about a new coalition that's bringing together NGOs, philanthropists, and a satellite company to change wildfire response. Muon Space is working with the Earth-Fire Alliance, a new nonprofit, to build and deploy FireSat, a satellite constellation that's purpose-built for global wildfire response. I'm joined by Cathy Olkin, former NASA scientist and now principal scientist at Muon Space, and Brian Collins, the executive director of Earth-Fire Alliance, about how this coalition came together, why it turned to space technology, and how it plans to bring new and accessible data to first responders, climate scientists, and governments. I'm Rachel Jewett, and you're listening to On Orbit, the podcast that asks, what's our future in space? Hi, Cathy and Brian. Thanks for joining us on the On Orbit podcast.
Hi, Rachel. Happy to be here.
Yes, awesome. So earlier this month in May, Muon Space announced plans for the FireSat constellation, which is going to be purpose-built for global wildfire response. And one of the things I thought was really interesting was that it was announced with the Earth-Fire Alliance, and you guys have involvement from organizations like Google, the Environmental Defense Fund, and the Gordon and Betty Moore Foundation. So I really wanted to hear more from both of you, Cathy from Muon Space and Brian from the Earth-Fire Alliance, about how this came together and what's involved with planning a satellite constellation specifically for wildfires. So Cathy, I'll have you get us started. Can you give us a little bit of background on yourself and Muon Space?
Sure, I'd love to. My background, I'm a planetary scientist, and I've spent a lot of my career working on NASA missions. I was the deputy project scientist for NASA's New Horizons mission to Pluto. And then more recently, I was the deputy principal investigation for NASA's Lucy mission. And I really wanted to turn my focus towards climate, and I started looking for a way to do that and found Muon Space. At Muon Space, we do Earth intelligence for a safe and resilient world, and this means really building, designing, operating satellites, constellations of satellites, so that we can understand the world a little bit better.
And then, Brian, tell us a little bit about your background before Earth-Fire Alliance.
Sure, thanks. And it's really excited to chat about this. So I am a space guy. So I grew up working on space, mostly from the military side, and coming out of a career doing military space, launching and building satellites, both as part of the old U.S. Space Command when that existed in Colorado Springs, and then supporting Boeing, the Boeing Corporation, and several other companies afterwards, and eventually ending up in an organization called the National Geospatial Intelligence Agency. Through the course of all those, and really starting way back at the Hayman Fire in Colorado Springs, started working with how space assets could really help support the wildfire mission. And way back in the Hayman Fire, that was generations ago in terms of wildland fire, where getting a large-scale perspective of a large fire was extremely hard to do. And that's when we started realizing that space gave a unique perspective to the types of wildfires that we have on our landscape today, which is really large, fast-moving wildfires that if your aircraft are there, you can see them right away. And if they're not, they move fast, cover a large area, and it's really hard to get a view of where they are. So my background really was starting in the military side, and then eventually moving into dedicating efforts and focus to the actual wildland fire problem, and really bringing a global perspective and a space-based perspective to how do we understand and work with the landscape we have today and the types of wildfires we have.
Yeah, wow, that's interesting. So how did the Earth-Fire Alliance come together, and how was FireSat? I guess it's kind of the big question of just tell me the story, how this all came together.
Well, we'll let Cathy start. So we started at different times. Cathy has the longest term with FireSat itself, and then I jumped in a little bit later. So how about you, Cathy?
Yeah, sure. So we've been researching this for quite a number of years. There's been a huge interest in understanding how we can use remote sensing to understand the mega fire crisis, because we have these huge, large fires that are burning across the landscape, fires that are more than 100,000 acres, and really getting improved intelligence to the fire management personnel for those critical decisions on resource deployment is so important. And foundations like the ones you mentioned, the Moore Foundation, EDF, have been essential for starting this effort. We had a formulation phase that began a few years ago, and we started working to understand, how do we really get at this problem? And then we kept continuing and improving the solution. And most recently, the Earth Fire Alliance was founded, and I'll let Brian pick up from there.
Thanks, Cathy. Cathy's been in the program or supporting this effort from the idea stage, which was really over 2 years ago, where it was really in the formulation stage, where a lot of the philanthropic community came together and started saying, what can we do? And can we do is a scientific effort. It's a study. It's a question. And Cathy really led that effort at Muon to really start looking at it from a scientific perspective, not a what do we want to do, but what can we do? I jumped in about a year and a half to 2 years ago, where we were focused on what is the contribution of space and how would it integrate with the operations on the ground. And that's my background, is really how do we apply it to the ground based on the experiences all the way from Hayman all the way up to recent fires here in Colorado and California, in terms of remote sensing. How does that actually used on the ground? So jumped in about 2 years ago on the user side of really how do we integrate it, and really building up in startup world, the use case, like what are we really going to do as we set forth. And then about 6 months ago, we decided we've understood the problem, and now we had to look at, well, how are we going to address that problem? Because to deliver this capability requires a couple of things. Certainly, you need a mission, you need a focus, you need a purpose-built effort system to do it. And we decided that a nonprofit organization, a 501c3, is the way to do this on behalf of the community, because this is not a small problem. It's not a regional problem. It's a global effort, and all of our supporters are philanthropic communities. So we decided that the best thing to do was to create a nonprofit to run this. And our mission as the Earth Fire Alliance is to deliver transformative fire data across the globe, a global data set that can help all different parts of the globe, different approaches to fire, understand what fire is doing to the landscape. And for us, the most important part of that, if you think about it, isn't stopping wildfire. It's understanding the impact of wildland fire on our landscape. So not all fire is bad. Some fire is natural. In fact, fire has been a natural part of our ecosystem since the formation of the Earth. What is important to us is what is its impact on what we're doing, both our life and property, and our climate, and our long-term sustainment of our ecosystem and biodiversity. And that is when we looked at this, we realized that is a broader mission than simply launching satellites. That's a nonprofit mission that is focused on delivering that transformative data to the globe. And that's where Earth Fire Alliance came from. So we took all that together and decided the best approach to do that was to set up a purpose-built system, that's FireSat, and a purpose-built organization. And our mission at Earth Fire Alliance is, we like to say it's observe, serve, and conserve. So we want to observe all of the planet's wildland fires and fire activity comprehensively. Doesn't matter where you are on the planet or what regime you live in terms of bioregime across the planet. We want to be able to look and provide information about that to everybody, from Indonesia to Western United States. And we want to serve communities because we want to give trustworthy, accurate data that can be used across the globe to make decisions about how best to address the impact on a landscape. And finally, there's a purpose for that, and that is to preserve our ecosystems and our biodiversity. That is why we're doing this. So that's why we stood up Earth Fire Alliance, was to serve a purpose above, using satellites as our primary tool, but to serve a bigger purpose.
Yes, I really admire, and I think it's really smart how it came from the purpose first. And it's like, it's focused on the purpose. And that's when you realize that you need to go to space, that it's not, space is cool or we're pursuing this technology. It's really built for the intent. So to talk a little bit more about the issue here, can you describe the scale and seriousness of the issues and challenges with wildfires right now?
Yeah, I can start and then Brian can add to it. The scale of it is just huge. It's global, but these fires are happening everywhere, and they're much more severe than they used to be because of climate change. And so that's why there's this critical need today to have better information, more frequent information, higher spatial resolution information. We spent the last 2 years interviewing more than 200 different people, from first responders, incident commanders, fire scientists, climate scientists, to understand what they're seeing and what their needs are. But when you look at the impacts of these major fires, they're in the news. Every headline you read, every day, it seems like I open up the news, I see something about fires. You can just think about the terrible loss of life that happens from these fires. An example is the approximately 100 people who died in the fire in Maui.
Yeah.
Of course, there's there's towns and areas at the wildland urban interface that are heavily impacted, loss of property, also from these large fires. In Australia in 2020, about 46 million acres were burned. That's about half the state of California. And these fires are just raging, severe fires. They're the kinds of fires that are going to impact the soil and the land so that the trees don't regenerate and regrow as fast as possible as they would otherwise. Not only that, those fires in Australia either killed or displaced about 3 billion animals. So there's this huge risk to biodiversity too, as you're losing this landscape. And we saw the large fires in Canada last summer.
Yeah.
So the impact is significant to loss of life, biodiversity, property, and also it's impacting climate as well, because these megafires are producing a lot of carbon dioxide that's emitted into the atmosphere. And that CO2 is undermining all the great gains that we're making over time. And so we need to be able to understand and account for it, and also be able to reduce the extent of these megafires. But it's really important what Brian said earlier, that there's good fire on the landscape and bad fire on the landscape, and this is going to be critical going forward.
Yeah.
Thanks, Cathy. The only thing I'd add, and she captured all of it, I'd add the number, as we look to the future, the number of projected high fire risk days are projected to increase annually over the next, perpetually, as we look towards the future. So the regimes in which we see these fires grow and move fast, and because of the climate that we're in, that's actually just going to increase over time. So our approach to how we even understand and look at wildfire has to dramatically change. We can't simply change and try and chase fire and attempt to, quote, put out all the fires that we have. That hasn't worked in the past. In fact, it's dramatically changed the fire regime in its own right. And at the same time, it's impractical to look at that. We need to understand how fire affects us and how it affects us differently in different global regimes, and how we approach it. One of the most interesting things, if you think about it, is there's all the costs of wildfire. Just in the US, the indirect and direct impact of wildland fire costs annually is like 400 billion. There's direct, and then there's the indirect cost on health and things, and that's just the U.S. But what's really interesting, if you look at, is those costs are about 46% are borne by the local communities that are impacted by fire. So I know we see this big effect of federal budget spent and state budgets and Australian state budgets and large organizations, but the actual cost is borne by local communities, even more at a global scale. In a community in Indonesia and communities across the globe where there isn't even a large federal or government response, those costs are entirely borne by those communities in terms of their cultural impacts, the biodiversity impacts. So we need to have a new way to look at it. And one of the things we haven't seen is a global perspective of the problem and a consistent global perspective. A baseline for the globe, if you want to think of it in a science term, is we all just need to baseline ourselves and understand it, to understand the scope and scale and start really looking at strategies to do it, to address that problem. And not just take a strategy from one region and apply it to the other, but simply look at a region's impact and say, I now understand the scope and scale of fire in Chile, or the scope and scale of fire in Oklahoma versus California. Those are, yes, Oklahoma is increasing because fire is moving east based on the climate change, but also how they approach it. So the statistics are alarming. We want to provide something that a capability and a transformative way to look at what's happening on the planet so that we can make better decisions.
Mm-hmm. Just seeing in the news, like it seems like you can tell just from reading the news how serious the issue is. And like last summer, the fires in the US were so severe. And I haven't had the experience of living in a fire prone area, but it's very scary to think about that for the people that are living it. It's really scary. So Cathy, I wanted to ask you, what were some of the takeaways and what were some of the things you heard during that, kind of listening to her and the responders on the ground that you guys interviewed?
Yeah, it's so amazing being able to hear from people who are fighting fires on the landscape and hear about their experiences and their needs. I learned a lot of things. I learned about the importance of not only understanding the state of the landscape during an active fire event, when there's a fire going on, the criticality of the very initial response, the initial attack on the fire, but also understanding the pre-fire and post-fire conditions. So how healthy is the vegetation in advance? Is there stress? Is there drought on the landscape? And how severe was the fire that passed through? So those post-fire conditions and understanding the area that was burned and the severity, and then that leads back into how will the landscape regenerate, and is there concerns about erosion or flooding? The other thing that's really interesting that we touched on was the concept of good fire and bad fire.
Okay.
So this good fire is a natural thing on the landscape, but we're in a situation where we have both good fire and these large, extreme, high severity events that are not only impacting the forest, but also the soil and the people who live nearby. And it's those bad fires that we need to be targeting. It's not about putting out every fire. I learned this from talking to all sorts of experts, that it's about understanding the fire and then making the appropriate response.
Okay. So then let's take that a step further. How do you take what was learned about the information that they need and how they want to use that information and design a satellite constellation to respond to that? Brian, I don't know if that's the right question for you or Cathy, whoever wants.
Actually, it's both of us, and I'll tee it up.
Great.
That directly affected the design and our approach to the program. We'll take the other side, is if we just wanted to detect fires, because that's any fire is bad, let's find the fires. That's a very different system design than understanding the intensity and impact of fire on the landscape. And that's why this program started years ago, but now we're actually executing the program, is that study and that analysis that says what's appropriate to understand the impact of fire directly led to us saying, we're not just detecting fires, we're understanding what their impact and their intensity is. So we use that at all those interviews, and then Cathy and her team did the design analysis to say, and this is how we'll address it. So Cathy, if you want to sort of jump in and say how that directly led to the awesome design that we have on the system.
Yeah, the user-centered design was key, and understanding from these conversations with incident commanders, for example, understanding that one of the things they need to do is to send someone out to see if there's really a fire right there. And that ties right back into requirements on the system. So if you are going to send someone, you need to tell them what roads to take, where the fire is, and how much uncertainty can you have in that? If there's a river, you need to know whether the fire's on one bank or the other bank of the river, or if there's a canyon, also really can affect how you get to the fire. So this drove the requirements on the accuracy of the location on the ground. It drove requirements as to how small of a fire that we can detect, making sure that we can detect a very small fire early before it becomes some raging fire. So we can detect fires that are on order 5 meters on a side. So like 5 meter by 5 meter fire. That's pretty darn small.
Yeah.
And that's because we have, there's new technology nowadays. And we can design a system to be able to do that by having a smaller footprint of our pixel. We don't have pixels that are 5 meters by 5 meters. They're actually bigger than that. They're 50 meters at nadir, so looking straight down. And so, but you can detect just 1% of that pixel being on fire. And so these requirements that were driving the system all came from the users. And then the way we designed the system was to look at what's been done historically. There are amazing assets out there observing fires right now. You've got observations from Landsat, GOES, Aqua, Terra, other missions. Now, those missions are doing a lot of different things besides just wildfire. So what we decided to do, focus on wildfire, make sure we're doing that really well. Those are large government missions, a much larger scale. So we're going to tackle a specific problem and go after that. The other thing I want to mention that we learned from the users was the importance of a low false positive rate. So if you tell someone there's a fire, they better go there and see there's a fire, or they're going to totally lose trust in their ability to use your data.
Wow.
And so that also drove the design for the instrument and this constellation.
That's a great point. That's really interesting. So is it an optical sensor, or like what kind of sensor is on board?
Yeah, it's a multispectral instrument doing broadband imaging from the visible to the long wave infrared.
Okay. And then Brian, how will this work in practice? So how will the data be disseminated? How are people going to actually access and use this data?
Right, and that's a great question to ask. It's also a really important part of the user design we went through. And first of all, I'll describe a little bit about the community of firefighting and fire response across the world. So our user base ranges from first responders to emergency managers to the public to science and fire science folks. So not just climate science, but fire science. Now, you could take the climate and the fire science folks as sort of the most sophisticated users we have. And so we want to make sure we're giving them very quality, accurate data consistent from the program. So they have everybody has access to all the data, but their focus is that really highly calibrated data that is consistent across the program. As we start moving left of that towards the public and first responders, we see some users, very sophisticated users. We have a partnership with CAL FIRE in California and here in Colorado, very sophisticated users that have decision support systems that can simply pull the data as we produce it. So we're going to produce that data in an API, a data service that they can pull from, and Earthfire Alliance is going to provide that data for free globally as we operate this program. So, but we want to make sure we're not putting a burden on the user. So it's a published API that they can pull the data into their decision support systems to make their decisions. So that's our primary dissemination mechanism is to have a process where they can pull that data. There's another side to it is we'll have a group of users that may not have that type of system. Those may be regional areas that you don't have a fire response agency. And that's one of our products is an alert product, which is a text message that can go out and say there is a fire here. Now that won't be the same high fidelity research level data that a research institute may pull from our API, from our data service, but it's still a product that can be available to the public as we walk out. So we're going to address both of those formats as we move forward. But the key to that is the global community we're talking to. So, and that's why Earthfire Alliance has Alliance in the name, we know there is going to be a global adoption program and period where we're working with Southeast Asia, we're working with other parts of the world that may have different cultural usage organizations that pull data, and that's where we're really focused on the alliance side, which is getting more partners into the Earthfire Alliance to represent that. We don't want to say we presume how a culture or a portion of the globe is going to use our data. We're going to build to the common denominator of a data service they can pull from, but we also want to partner with to make sure we actually meet them where they are. The worst thing we can do, and my technology background is force folks to use a piece of technology they're not used to using in the time of crisis, because it won't be used. So we want to make sure we're going to build to a data standard that is easy and low cost to build to, but we also have a mandate to partner with regional agencies across the globe as we roll out the program within our launch cycle. And we haven't sort of touched that, but we're on a pretty tight timeline. Our first test systems will go up next year. We'll have our operational satellites in 2026, which means we have a short runway. We have essentially 2 years to start building that up, and that is sort of our part of chatting with you is to build an alliance of early adopters that are going to help us globally prepare for cultures and regimes that we may not have thought about how we're going to share that data.
That's awesome. So who's your call out to get in contact? Like who are you looking for to partner with?
Cathy can jump in too. We have a broad user community. So there is the fire science community and the climate community. So that is one, because that community is going to prepare us to use this data from a long-term perspective. There is the next group that we're looking to is first responders, and that is a global first responder. So that isn't just a local fire, it includes the local fire departments as well as regional emergency management agencies. And there is a piece of the concerned public that is that is another piece is how do we fit into the public awareness of fire? The public can do that both certainly through their first responding agencies and their local government, but also just looking and coming to earthfirealliance.org on the website and being interested in the program and providing some inputs of how the public should view our data. We definitely view across the board as a transformative public service data set. So how do we integrate across all those? It's not just for one or the other, but it's across those.
Mm-hmm. Yeah, I think that's a great point that you're thinking about how different communities are going to be using the data from, the needs of science community that is, knows how to use the data to, people that it could be really valuable for, but maybe aren't used to engaging with this type of satellite data. So I think that's awesome.
Yeah, and when we look at those different communities and their needs, we see that there's a different timeliness that they need the data at. So if you're
Okay.
responding to an active fire, that's one thing. If you're trying to understand CO2 emissions into the atmosphere, that's a different timescale. So it's interesting to think also about how that interplays into the data and the delivery of the data.
Mm-hmm. You mentioned that the data will be free to users. So who's paying for it?
Right. So right now, this is a philanthropically funded program. So that is our mantra for getting through our first initial operating capability. And for us, that is our operations through the end of 2027, which is launching and operating our first 3 satellites. So we are committed to doing that philanthropically. And so these are large scale foundations. We haven't entered GoFundMe yet, so we're focused more on large climate, environmental, and social organizations that share the mission with us, which is transforming how we address these crises in the globe. Long term, after 2027, we know that as our data sets grow, they become much more integrated with large scale data sets from government agencies. So we're serving an interim gap, and then we're going to build as we go. After 2027, we envision a public-private partnership with the government, with large-scale government organizations and research institutions who are going to continue to research, use, and provide access to our data.
Mm-hmm. That's great. I appreciate, and I think it's amazing that foundations are willing to invest money in this and get this off the ground, because it's a public good. It's something that foundations should be getting behind.
Yeah, I agree. I'm so glad that the foundations are interested in this and active in this and making sure that this is happening for everybody across the world. And it's really a testament also to the aerospace engineering, industry and how aerospace has changed over time, and with the new space revolution become more affordable launches, more affordable technology, really to enable this, so that we're now branching out of just government funded large satellite systems to other alternatives. It's very exciting times.
Yeah. Muon Space. Does Muon Space build the satellites themselves, or are you like contracting them out? Can you tell me a little bit about the manufacturing side?
That's right. We build our own satellites, and we build them in Mountain View, California. Very exciting, in our facility there, which used to be the home of Skybox, where some of our founders came from. So it's kind of returning back to their roots. So with this deep experience in across our engineering and scientific staff, we're able to build the spacecraft, build instruments, deliver data, operate the spacecraft, and really work across that whole range of the industry. And we have 2 satellites currently flying, and we will be launching the next ones in 2025.
Okay, awesome. Yeah, and Muon Space, there's other satellites, not just for the FireSat constellation. Is that correct?
That's correct.
Okay.
Yeah. Our first satellite was really, we built and designed our own avionics stack. And so the first satellite was really, a test bed, proving out that works and continuing to be able to iterate fast and learn. And so it's on orbit, and we make improvements and upload new flight software and capabilities, and we can test it before we're doing things like the first FireSat satellite. And this really helps to reduce risk across the program as well.
All right. So for my last question, I want to ask you both, what is the impact that you hope this will have, say, 5 years from now, a few years after it's been launched?
I can start. I'd really like to be able to say, we helped save firefighters' lives. They had information they wouldn't have had otherwise that helped them to be safe. Also, I want to be able to say that we helped prevent megafires. So looking statistically at megafires, and by being able to respond early when they're small and be able to reduce those terrible impacts to the landscape and the public. So those are some of the big impacts that I'm looking forward to. How about you, Brian?
Yeah, it's similar. One of the things, because we do talk a lot about understanding beneficial fire, is interestingly enough, one of our metrics, and we are tracking like what our impact is for this program long term, is when we first started, it was reducing the acreage burn. And our new metric is reducing the percentage, not the number of acreage, but the percentage of acreage that is severe and has a severe impact on the landscape from where it is today. So, and we're now, there are studies that we're part of, which are tracking, even here in the United States, by state, which of the land and acres that are burned in a fire, what percentage are severe, what percentage have a negative impact, and what percentage are in what we would call beneficial ecological fires that burn. And so we want to rebalance that. And so our first metric, certainly there is reducing hoping that we reduce life and property risk and impacts of fire. One of the metrics to do that, it's very hard to do when fires are going to increase no matter what. We have this weird background, which is you can say you're going to do better, but your environment is that no matter what we do, even if we're great, we're going to increase the amount of fires that are on the landscape because of our climate impacts. But what we can track is the percentage of those fires that have a severe and negative impact on biodiversity and on our life and property, and the ones that don't. And so what we would like to see within 5 years is across the United States and the globe is first being able to track that. We have never in the history of the planet been able to track that. So the first thing is to track that globally, get a baseline. And then once we get a baseline, start to see that we impact the decisions that change that landscape. So that's something we don't own on ourselves. All we can do is provide the data, but what we can do is baseline it so we can increase global awareness. And then through that, start to see increases in beneficial fire percentages and decreases in severe fire percentages across the globe.
Yeah, that's really interesting. Well, I think you guys have brought together just a really impressive coalition, and it's so cool to see something that is purpose-built for such an awesome purpose, where you have philanthropy involved in funding it. And I wish you guys the best of luck as you're getting this constellation up, because it sounds like it's really needed and it's such a critical issue.
Thank you.
Yeah, thank you, and thanks for giving us a chance to share about it, and our partners to share about it. I mean, this is the effort of the 200 plus experts that have helped us. And those are user experts, not even just the engineers at Muon, but that's the user team, and then the interest and support of folks like EDF, Google.org, the Moore Foundation, and really driving this as their support. And mixing, it's an interesting thing to mix a climate and an environmental initiative with technology. That's a very unique mission. It takes a unique drive to get there. So we really appreciated both of our first responders, the climate scientists and the fire science, and then the supporters, to realize that intersection is worth the time to do it and purposely doing it. Not, yay, we have a satellite, but really drive it because there is a unique intersection that we can address. So it's really exciting, and it's really exciting to share it. If you can't tell, we love talking about it. And thanks for letting us to share our perspectives on it.